of my research paper. That is the grade 1 leaf images, yellow leaf Carl virus images, grade 1 images. I have found that all the ranges of severity score of grade 1 images ranges from picture shows that the severity score of yellow leaf gall virus is grade 2 images, where grade 2 images ranges severity score of grade 2 images ranges from 51.92% to 63.40%. And this is the cluster validation index. After obtaining the clustered images using the k-means and fuzzy c-means, I use two internal indices. That is, I refer also that they validated for David Goldin and Kalinowski-Harbus index, and these graphs with these graphs for the David Goldin index of yellow leaf gall viruses, where optimal cluster number for sample 1 I have found it is 3, and optimal cluster for sample 2 I have found that it is 2. This is the CH index for grade 1 images. That is both samples are I have found that optimal cluster number is 4, and this is the DB index for grade 2 total leaf images. Here optimal cluster number 2 is equal to is 2 and 3 for sample 1 and sample 3 respectively. And this is the graph for CH index of grade 2 tomato leaf images. Here optimal cluster number for sample 1 and sample 2 is 2 and 3 respectively. In the conclusion section, this is my conclusion slide, and I in conclusion, I can say that our unsupervised clustering approach provides an efficient way to evaluate tomato leaf disease severity, and future will focus on integration, real-time IoT application with smart farming, and the addressing limitation like the reliance on high quality of data set. And these are the so many. I have used so many references. Some of the key references are listed here. And this is the thank you slide. Thank you for your attention and time. I will look forward for your questions and feedback.
Thank you. Any question from audience? Any question? Sir, any question?
Yes, sir. I mean, PEC already 256 into 2 calculated as I have found all these.
Provide different size of images as input. Then your model will work on structure.
Yes, sir. Yes, sir. Yes, sir. It is based on k-means and fuzzy c-means algorithm.
So your work also you did not make any comparison with the existing work.
No, sir.
Okay. Thank you, sir.
Thank you, sir.
হয়ে যাবে
তিনটে চার বাজে ওটা করতে হবে, ওর ট্রেন আছে, বেরিয়ে ওটা করো, তারপরে দেখছি, তারপরে আচ্ছা একটু শর্ট। হ্যাঁ আচ্ছা, ওটার পর ওটা হলে তারপর দেখছি 3:30 বাজে।
চেঞ্জ হচ্ছে না এটা
3টে বাজে। হ্যাঁ হচ্ছে তো।
Good afternoon, everybody. Myself, Bodhisattva Boiddo. I'm a research scholar from Ramakrishna Mission Vidya Mandir, Belur Moth, and my co-authors are Dr. Atanu Mandal, Sarvajit Manna, Gaurav Das, Anirban Shatran, Orkoprabhu Chakraborty. So, I'd like to ask everybody, do you have any kind of idea about UAVs or drones? You guys heard about drones, right? Okay. So, our research is, to be honest, UAVs are increasingly used in various sectors. Just like in the border, we can see militaries are using for the transportation, for the logistics. Everywhere, drones are using. And to be honest, for accurate, is it audible? Okay. Okay. So accurate tracking is vital for the safety and, to be honest, air traffic management and surveillance. And our motivation is like a single sensor tracking system. It faces challenges for accuracy and robustness due to the external environmental factors. So, motivation to enhance UAV tracking accuracy and robustness in diverse environmental directions to address the address the many negative points of single sensor systems. And our contribution is like development a multi-sensor fusion, just like instead of a single sensor, just like radar, just like velocity sensor, we have implemented of 4 to 5 sensor combination for the tracking and movement of the drones or UAVs, we can say. And after the simulation, we got like 12.5% of improvement from the single sensor. So some of the methodologies we can say in the state vector, state transitional model, measurement model, process noise covariance, and measurement noise covariance. So in the state vector, we have here we define the state vector into two components, just like one velocity and one in the directional component. In the directional component, we have rho, theta, phi. After that, nu rho, nu theta, nu phi, etc. Rho equals to we define like distance to the origin, and theta we define the angle to the horizontal plane, and phi defines to angle to the vertical plane, and nu rho defines to the changing speed of the origin, and after that it's continuously nu theta equals to changing speed to the horizontal angle, and after that nu pi changing speed to the vertical plane. And after that, state transitional model. So I'll give a small example like that. So if we are throwing a ball, okay, if we are throwing a ball, how can we detect where in which direction or which velocity that ball will gonna land? So for that, we have used state transitional model. In the state transitional model, we'll be predicting that UAVs or drones next step. In the next step, where drone will gonna fly or hover. So those mathematical models I've used, and in the measurement model, we have used that sensor measurement, and in the process noise covariance, we have used the uncertainty of the drone's motion with some measurement error as well. And after that measurement noise covariance also, we have used same kind of uncertainty, but with the time that a simulation will gonna run, the real life application scenario will be fetched. So apart second methodology is EKF implementation. EKF extended Kalman filtering. So I'll deep dive to it. It has 2 steps, just like prediction like first where the drone might be next timestamp, and second calculate how uncertain the guess is, just like we're guessing where would be the drone in the next step. And after that, we'll update as per the EKF. We then compare the our EKF guess to the measurement sensor measurement we have got. And second, we'll then adjust the prediction to the drone's actual location. So apart from that, some of the proposed methodology of sensor model. So in the sensor model, we all know like RF sensor. Sensor is like measuring the signal strength, and radar is measuring the direct distance to the drone from the ground station. And radar velocity measuring how fast the drone is moving. An acoustic model is just like they are creating sound like pattern. And optical sensor directly measuring the drone's portion with some visual measurement errors. So these are the results we have got in RF sensor. I have done this simulation in the MATLAB itself. I think Sir sometimes ago told about MATLABs and all. So in the sensor data analysis, RF sensor, we got mean signal strength, standard deviation. Apart from that, radar mean velocity, acoustic center, mean tracking error, and mean tracking error EKF. Here, please just see like that. In mean tracking error on optical, this is like 0.08 meter. But our estimate Kalman filtering got 0.07 meter. Some 5% of improvement we have got it. Next. This is some of the graphs we have got through MATLAB. In here we can see significant in the RF sensor, significant signals strength fluctuation we have seen, just like is going down. Okay, and in the radar we can also see like that some of the intermediate dropouts are there. If we I think there is no option for zooming. So if we zoom now, so there in the blue section in the radar range, some of the lines are missing. So this is like intermediate dropouts of the data. And next, radar velocity. Radar velocity we can see a kind of constant, and acoustic is like a sinusoidal pattern they have created. And here we have combined all the sensor. Instead of one sensor, we have combined all the sensor of RF, radar, acoustic, and velocity. And we have also compare it to optical and EKF estimation. So we have got 5% of improvement from optical. Throughout the error also EKF performs well throughout the GCS2 EOV. And after that, EKF estimation, smooth tracking performance, smooth perform tracking also there. And apart from that, KL it can demonstrate the clear observation of the EKF ability to handle the non-linear programs as well. And here we have also differentiate some of the EKF and true optical and normal optical. Here we can see in the two section is there. Blue line and red line is also there. Blue is the prediction and red line is the EKF. So as per the guess where the drone's next position will be there, that red line follows and kind of showing the 12.5% of accuracy. And here we have compared with as we have used extended Kalman filtering. Apart from that, unscented Kalman filtering and particle filter, we have compared like that, and our EKF performs well, and 5% of improvement is there. And some of the result section, as we see, some of the simulated radar dropouts of 5% probability of NAND readings are also there, and some of the adaptive measurement noise covariance, that equation also we have used. And some of the conclusions are the research demonstrates efficiency of multi-sensor fusion and EKF in enhancing that UAV and tracking capabilities instead of one sensor, and it provides a practical implementation where many different weather condition as per sometimes in the military also, where what is going on, one sensor is default, one sensor is not able to work, then we can multiply the sensor and do it like that. And it shows like 12.5% of improvement in tracking accuracy. And future work, we can explore the advanced sensor fusion technique and non-linear filtering method. Apart from that, many AI we can also use. So some of the reference we have used, some of the 10 reference I'm just filtering out. And thank you. Any questions?
Any question from audience? I think there is no question. So thank you.
Thank you, everyone.
এটাই লাস্ট এখন নিচ্ছি আমরা।
আরেকটা হয়ে যাবে?
একটা থেকে 10 মিনিটই করতে হবে।
হ্যাঁ, হয়ে যাবে।
হ্যাঁ, বেরিয়ে যাবে।
হ্যাঁ করে দিচ্ছি, এই অনেকগুলো খোলা তো একটু বন্ধ করে দিই। কোনটা বলো তো?
কিভাবে আসছে সেভাবে।
এইটা ডিপ লার্নিং।
একটু সময় দিতে হবে।
হ্যাঁ,
11 না? 11
A very good afternoon, respected dignitary, research scholar. A very good afternoon, respected dignitaries, research scholar, and all the students present here. I am Devani Chandu, research scholar from the University of North Bengal, under the guidance of Dr. Rakesh Kumar Mandal. I am going to present my research paper, Deep Learning Enhanced Detection of Light Tendencies through Answer Pattern Variation. Light detection is crucial. Light detection is crucial for security, recruitment, and criminal investigation. Some traditional methods like polygraph rely on physiological signals such as heart rate, pulse rate, etc. But they are prone to manipulation and cost effective. Another methods like pattern variation method using ANN and pattern variation method with modified weight using ANN are use simple questionnaire technique. They mainly focus on consistency by asking the same question repeatedly, but they fail in rehearsed lies. This research addresses this limitation with a novel approach using deep learning to analyze behavioral and textual data. There are so many limitations in the traditional method, like polygraph needs some specialized equipment and it's cost effective. Most of the machine learning models are mainly focused on text and structured data, but they often ignore behavioral features. So our goal is to develop a scalable, non-invasive system that achieves high accuracy in detecting lies, making it practical for real-world applications like interview, background checks, and security screenings. The proposed methodology integrates behavioral metrics derived from seed dataset and textual features from a publicly available dataset, which we collect from Kaggle and GitHub. They are liar and deception opinion spam dataset. The seed dataset are constructed by asking questionnaire technique. Here, the questions, repeated questions are asked, but in different way. And after that, both the data, all the data from the datasets are combined to create a single dataset for the robust light detection technique. As you see, this is the combined dataset. Here, this is the sample image of the combined dataset. Now, this is the block diagram of the proposed methodology. The first thing is to calculate the behavioral metrics such as response consistency and response delay and unexpected questions ratio. Response consistency measures the variation between the answer pattern and repeated answers, and the response delay tracks the time taken to give answer. An unexpected question ratio calculate the reaction or observe the reaction of unexpected question. And textual data is embedded using Pit and BART, which captures semantic and contextual refinements. This is the deep learning architecture as shown in the diagram. That our deep learning architecture include a behavioral branch which process SIT data through dense layer, and textual branch which this is the textual branch which takes text data using bi-LSTM network, and the integration layer, and this is the integration layer. Integration layer combine both the branches for the analysis, and the output layer here is software classification is used to predict the probability of truthful and liar. Now come to the result analysis section. As we can see that our proposed model achieved an accuracy of 89.5%, a precision of 85.7%, and a recall of 92.4%, and a F1 score of 88.9%. So we compared our model with some existing model. That is the first one is CNN LSTM model developed by Mendels in the year 2017, which achieves 86.2% of accuracy and 90% of recall. Another model, multimodal neural network model, developed by Krishnamurthy in 2018, which achieve 88% of accuracy and 91% of recall, while our model achieved 89.5% of accuracy and 92.4% of recall, making it as you see that our proposed model result based in comparison with the both the models. This demonstrates its capability to detect lie pattern more effectively by combining behavioral and textual features. This is the ROC curve. This is the ROC curve of the proposed model. As shown, it's closer to the left part corner of the ROC part is closer to the top left corner, which indicates best performance, and the AOC that is 0.75, which closer to 1 indicate the best classification performance. So in conclusion, we can say that this research introduced a novel deep learning based deception detection model that integrates both behavioral and textual features, achieving high accuracy of 89.5% and a F1 score of 88.9%, which outperforming traditional methods. The model is non-invasive, scalable, and applicable in areas like security, recruitment, and law enforcement. And there are some future work is also directed here that we can focus on diversifying the training data set of the seed data and vary the behavioral patterns. And we can refine the seed data set and introduce some other features like video and audio, etc. Thank you for your attention. I am happy to receive any kind of questions or give valuable feedback.
Any question? Any question from audience?
One question.
Yes, sir.
You have compared your model to 2 or 3 other models.
With two models, sir. One
Two models which is proposed in the
Sukanta
year
and Mendel.
in the year of 2017 and 18.
Yes, sir.
Did you? Is there any other model that was proposed recently?
Actually, sir, I didn't find the model which works on textual data. So most of the data are used with voice and video and EEG signal, but I didn't find any of the work on textual data or behavioral patterns.
I also don't know that whether there is any model that was proposed recently or not.
Yes,
But we should find it.
yes, sir. Obviously, sir.
Okay.
Thank you,
Another
sir.
thing in your comparison,
Yes.
whatever the proposed methodology,
Yes, sir.
you have used SIT, LI, AR, and deceptive opinions.
Yes, sir.
But other two models, they have used different data set, na?
Yes, sir. Mendel use audio plus text, and Krishnamurti use real life.
Real life.
Real life.
Okay. Whatever data set you have used,
Yes,
is there any proposed or existing work in literature who use this similar data?
Yes,
And
sir. Yes, sir. But I didn't include here. The some works on liar data set and deceptive opinion spam data set. And seed data set is constructed by we constructed them. Seed data set.
okay, thank you.
Okay, thank you.
আচ্ছা আরেকটা 5-7 মিনিটের মধ্যে করলে আমরা ঢুকে দেবো আপনাকে।
হ্যাঁ
তো স্যারও দেখে দেবেন স্যার। আরেকটা করলে
আচ্ছা আচ্ছা
বাকি অনলাইন গুলো আমরা পরে করছি।
ইয়ে দেওয়া আছে পিপিটি দেওয়া আছে
না পিপিটিটা আমি ইয়ে পাঠাচ্ছি একবার সিএস এ পাঠাচ্ছি। তুমি ওখানে ঢোকো সিএস এর মধ্যে ডাউনলোড করে নাও যাও তাড়াতাড়ি।
করো তাদের করে নাও
বেশি সময় নেবে না রবিন, আমি কিন্তু মাঝখানে বন্ধ হয়ে যাবে তাহলে।
সে না হয়ে যাবে
হ্যাঁ কারণ আমি তো 10 মিনিট আগে ওনাকে টাইম দিতে হবে।
হ্যাঁ আমরা রেডি করতে হবে
আরেকটু ভালো আপনি যদি কিনোট কিনোটটা সাথে কথা বলতে হবে। ওটা দেখি আমাকে যে গ্যারেজে না বুঝতে পারছি না আপনি তো কাছে হলে সিএস এ ঢোকো গেটে নিয়ে যায় না কিন্তু সব
না সিএস এ ঢুকলাম,
ঢুকে ডাউনলোড করো তাড়াতাড়ি। হ্যাঁ এটা তো
এটা রতন স্যারও পাঠিয়েছে।
হ্যাঁ এটাকে বড় করো প্রেজেন্টেশন মোডে যাও।
স্লাইড শো
এই তো করে আছে এই ফেকুলে তো এই তো এই যে হ্যাঁ হয়েছে ওকে তো লেটস স্টার্ট। এই রমানিয়া না রবি না 25 বারে
মাটো তো ইলেভেন ফর 86
Good afternoon, everyone.
Good afternoon, everyone. So, good afternoon, my teacher, my dear teacher, Arkem sir. Good afternoon, sir, everyone. And my topic is an efficient elephant detection strategy using visual attention network WAN in custom data set improved yellow V model. Okay. So, next one. Hmm. So background here, I have used the elephant where the elephant actually elephant. Why we want to detect the elephant? We want to detect the elephant as because we have certain issues regarding elephant because elephant human some problems are there that some hotspots are there and uh, that hotspots like railway or roads the elephant accident may happen elephant cause problems to human so that's why we want to detect elephant so here previous that's Shugumar and Jayawar they have also did this work through computer vision and also in our previous works that Arkem sir also had did this and also our Didi Bhutia madam also did that work. So I have also referred that work as 2 and 3 as my reference. So I have got the motivation from 2 3 papers. That papers are just for uh, detecting the objects. Just like yellow is detecting the object and also self attention. So here I will go to the next slide. You will get that thing. So here yellow. What is yellow? Yellow is not the color. Yellow is a once only you look once. That is a algorithm, machine learning algorithm used to detect objects. So here, the yellow algorithm is used to detect several objects. Already, I have given the picture. In that picture, you can see the algorithm is detecting the different objects. Here, the objects are what different animals or different species. So here, this is the 2023 paper, Visual Attention Network. This paper, it is here, it is given there that the self-attention of a image can be done. So here, what is the main thing that is same image can be used to enhance by region of interest. My own contribution is when a elephant will enter the webcam will capture the elephant data means elephant picture and it will send to Google Colab there the yellow and visual attention network we will apply that one and it will detect the elephant and it will send the signal to the concerned authorities. So here I have given this total work in the 3 stages. Step 1 is for the Google Colab project and second stage is to annotate the image. If the image contained the elephant, yes, we will consider it as a data set and if not, then we will again do the modify the data set. Then third stage, the actual yellow and van, we will integrate this thing and we will detect the elephant and then send the message to the concerned localities, officials, forest officials and the local public or people. So here for annotation, we have used the label image tool. So we take the data collect from the Kaggle website and also Zoneto. One website is that Zoneto or something. I had already mentioned here in the reference at the last that African website. From there we have already taken the images, elephant images, and then we have annotated the image with the IMG level image tool and we train the images with yellow V model and visual attention network. So this combines our improved model. So how we have integrate the WAN with the yellow V7? We have integrate that by input image will be detected by the yellow V. Yellow V will detect the object, and then the region of interest, that is ROI, will be extracted from the bounding box, means the detected objects, and then the final output with enhanced attention will be as our result we will get. So here in the results, I have taken binary classes, means two binary classes. That is one positive elephant, that in the right hand side you can see the elephants are present, that set of class, and negative means non-elephants, means cow, dog, monkey, like that. The elephants are not present, that is negative elephant. Okay, so no elephant. So here 5,535 total images are used, and in this, in the positive, we have taken for training purpose, we have taken 3,165 images, and for validation, means testing, we have taken 1,159 images. So here is the comparison between the improved yellow V model with the simple yellow version model. Okay. So this one is the custom confusion matrix of the our simple yellow V model, and this one is the custom one, that is improved yellow V model. Sir, conclusion. I am coming to conclusion. Conclusion, here we get the accuracy as correct predictions by total predictions. Total predictions means all the predictions, they true, positive, true, negative, all the things. And the correct predictions means only the true positive and true negative. So when we divide this true correct predictions by total predictions, we get 0.97 accuracy, that is 97% accurate our model it shows. During testing, means validation time, and this is one is our references. All this here at the last you will get the all the three data set I have used. Thank you.
Thank you. Thank you, Robin. Any question from audience?
You got 97% accuracy.
Go to the result section.
Yeah, please go to the result section.
TVS আসছে না।
না না, এটা না, আগে যাও, কম্পেয়ার সেকশনে যাও। Compare your system with which method?
Normally,
Improved yellow V model with yellow plus WAN, means visual attention network. That is the fusion of WAN with yellow version.
So data set you have used? What data set you have used?
That is binary. Binary already custom data set I have used from the Kaggle and Zenodo.
Okay. And you got the result 98%, 97%.
Yes.
Okay, fine. It is a good result.
Yes, sir.
Thank you.
Thank you, sir. You have question. Okay.
ডেটা সেটের টাইমে ইএস ডেটা যেটা ছিল পজিটিভ সেটা 4000 সামথিং এন্ড লো ডেটা যেটা ছিল সেটা 700 ডিফারেন্স কি কোনো প্রবলেম ক্রিয়েট করে যে পজিটিভ আর নেগেটিভ বাইনারি ক্লাসিফিকেশনের সময় পুরো পজিটিভ সেটা আছে 3000 সামথিং এন্ড নেগেটিভটা 700 ডিফারেন্সটা হয়ে গেলে কোনো প্রবলেম ক্রিয়েট করে
না, খুব বেশি ডিফারেন্স হয়ে গেলে তখন তো আমাদের F1 স্কোর তখন দেখতে হবে টু মেনি ক্লাসেস এর সময়। তো এখন তো অনলি আমাদের বাইনারি ক্লাস আমরা নিয়েছি, তো নো প্রবলেম। কেন কি সেম ইকুয়াল ব্যালেন্স ডেটা সেট আমার নেওয়া হয়েছে। ইমব্যালেন্স ডেটা সেট নিলে তখন প্রবলেম হবে। ঠিক, থ্যাংক ইউ, বোঝাতে পেরেছি, থ্যাংক ইউ,
Thank you,
থ্যাংক ইউ,
Ravi.
থ্যাংক ইউ।
Thank you.
চেষ্টা করে রেডি থাকতে হবে, ওটাকে তো বলা যাবে না কল রেডি থাকবে। একবার ফোন করে নালে না না, ফোন ওইভাবে ডাইরেক্ট করতে হবে না, করতে গেলে অনেক সমস্যা হবে। কিছু অ্যাডমিট করছে ঢুকে কে কে ঢুকাতে হবে না, পরে দেখো এই যে ভেংরা, এলিজা ভেংরা, হ্যাঁ এটা হতে পারে, জানি না ইনি কেন এলিজা কি
वो बिजनेस है वो लास्ट खन्ना का रिसीव
Thank you, Madam and Sir, for your valuable session. Now I will again welcome our Honorable Session Chair, Dr. Subhash Burman, Sir, to please come up on the stage to host the program for the rest. Thank you, sir.
না উনি শেয়ার করতে হবে তো সেটা কাকে শেয়ার করবে উনি তো
নিয়ে যাও এটা একটু
এই কাগজটা দিয়ে
ওয়ান সাউন্ড নিয়ে যাও তো কাজে লাগবে এটা তো হাত
ওটা ওখানে রেখে
অনলাইন শেয়ারিংটা অন করব পিস্তল তো লাগবে
আচ্ছা এই আমার ক্যামেরা শেয়ারিংটা বন্ধ করো, ক্যামেরা শেয়ারিংটা বন্ধ করো। উনি শেয়ার করবেন তো?
আমি শেয়ার অফ করেছি তো।
আমরা অফ করেছি স্যার, এখান থেকে বন্ধ করা আছে,
ক্যামেরা তো অফ করেছি। আগে পিন করলে আমাদের চলে আসবে।
He is currently proceedings covering the application of meta-heuristic methods in unconstrained and constraint optimization, multi-objective optimization, engineering designs in electrical and mechanical fields, power systems, multi-criteria decision making, solar cell design optimization, and wind farm layout optimization. Recognized for his exceptional contribution to the field, Riz Allah was consistently ranked within the top 2% of scientists worldwide by Stanford University in the field of AI for the years 2020 through 2023. He awarded a prestigious fellowship in the Czech Republic, recognizing his outstanding contributions to the field of engineering mathematics. His research interest includes many objective optimizations, rough set theory, fuzzy set theory, intuitionistic applications, fuzzy set, nucleosophic set, and renewable energy systems. Additionally, his expertise extends to the application of meta-heuristic optimization techniques in computational engineering and operation research problem, alongside his notable focus on green hydrogen technologies. And today we're very much lucky to have Dr. Rizallah, and we hope we will get few ideas about his current research work. So now I would like to welcome Dr. Riz Allah to share his research work. Sir, please.
Over to you, Professor Rizk.
তোমরা টেলিফোন অন হয়েছিল মোবাইল মোবাইল অন হলে পরে দেখো মোবাইলটা এখানে লাগিয়ে দিই তাহলে সাউন্ড হবে না।
ওসব করার দরকার নেই, যেভাবে হচ্ছে হোক।
না না
এই
মোবাইল
soundটা আমরাই শুনতে পাবো, উনি শুনতে পাবেন না।
ঠিকই আছে, কিন্তু মোবাইল যদি কেউ দিই মোবাইল তাহলে ওদিকে চলে যাচ্ছে, আমি এখানে মিউট করে রেখেছি।
এটা কি শেয়ার করা হয়েছে?
ওটা সাউন্ড আসছে।
আগে জিজ্ঞেস করো তুমি গিয়ে, স্যার আর ইউ অডিবল? এটা যে সাউন্ডটা এখানে আমি তো অফ করে দিলাম, তার সাথে ও এইটা দিয়ে হয়ে আছে,
অনেকটা মিউট করে দিতে হবে।
এটা যে অফ হচ্ছে ওখানে হবে না। এটা কোন
মিউট করে দেবো। দেখো তো কে জয়েন করেছে এখানে,
এটা কোন করেছে?
এই এখন জয়েন করে দিলাম। না কম্পিউটার সায়েন্স দিয়ে কেউ জয়েন করেছে, এটা মিউট করুন।
Sir, please unmute yourself. We can see that you are muted.
Hello, Professor Rizk. Is it audible to you?
Hello, sir. Please unmute.
It's okay now? Yes, okay now?
Yes, sir. Yes, sir. Please start.
Okay, thank you so much. Thank you. Hello, everyone. I would like to thank Professor Sidarsa and the organizer for this symposium to be with you, to giving me this opportunity to be here today. Firstly, I am Professor Rizk Masoud, and I am Professor Engineering Mathematics at Monofia University, Egypt, and the senior researcher at VHB Technical University of Ostrava, Czech Republic. We are going to talk about hybridization of computational algorithms. So outline for this introduction to meta-heuristic and hybridization, motivation for hybridization, taxonomy of hybrid algorithms, disadvantages and the challenge for hybrid algorithms, recommendation for future and developments and references. Meta-heuristic. Yes, Professor.
Pardon, sir?
I don't know how to manage this, but I will try. I saw my screen, but I don't know how to manage this.
Sir, are you changing your slides there?
Yeah, I will try. Give me a second.
Yeah, okay, sir.
It's okay now?
Slide is, yes, it is visible now.
Okay, I will give you a slide. Give me a second. I school, but I not work. I don't know.
দেখো আমরা ভিডিও অন করে
Okay, okay. Give me a second.
এটা একটু ঘুরিয়ে ঘুরিয়ে দেবো হ্যাঁ তাহলে তো করে দেওয়া যাবে আর আমি সিএসএ পাঠাচ্ছি তুমি তাকে ডাউনলোড করে
পিপিটি পাঠিয়ে দিয়েছেন উনি
ডাউনলোড
Hello, sir. Yeah.
সিএসএ ডাউনলোড করো না
এই আমাদের বিল করে রেখে বিল করে
Okay, Professor. Okay. Thank you. Okay, Professor.
শেয়ার হয়েছে
শেয়ার তো হচ্ছে
হয়েছে নিশ্চয়ই তার ডাউনলোড করেছো
So I can start now.
বলো বলো
স্যার আমাদের তো খোলা আছে সাউন্ডটা খোলা আছে
না না এটা না ক্লোজ করো স্যার ওয়েট আ মিনিট জাস্ট showing you that.
Sorry for this disturbance because I didn't use Google Meet more time, but I usually use Zoom meeting. Sorry for this disturbance. So outline introduction to meta heuristic and hybridization, motivation for hybridization, taxonomy of hybrid algorithms, disadvantage and challenge of hybrid algorithms, recommendation for future developments and references.
এইভাবে নামিয়ে নামিয়ে ওনাকে
So we're going to talk about the definition of meta-heuristic algorithms. Meta-heuristic algorithms is a tool for that mimic some biological and physical. This category of this meta-heuristic algorithms can categorize to many classes like evolutionary-based, physical-based, swarm-based, and so on. Evolution-based is inspired by natural evolution, like genetic algorithm, simulated annealing, evolutionary strategy, and genetic programming. The second class is physical-based methods. This imitate or mimic physical rule, like simulated annealing, gravitational search, and charged system search. Swarm-based techniques, this mimics the behavior of group of animal. The most popular algorithm is particle swarm and column optimization. So we have four categories of meta algorithms: evolution-based algorithms, physics-based algorithms, swarm-based algorithms, and human-based algorithms. There is more categories of meta-heuristic algorithms, but this like pure algorithms. So when we face like challenge problem like multi-optimal or high dimensional problem, we need to develop more robust algorithms like integrating some or two algorithms together or hybrid some algorithms or make some integration. So this is like list of pure algorithms for swarm algorithms like BSO, like honeybee colony, like AB colony, and so on. So, common future in solving any problem is how to go to exploration and exploitation phases. So exploration means we need to make more diverse algorithms. So we need algorithms that can explore all the search area. And exploitation, it's like intensification. We need to make local search. So local search can make more precision or more accurate solution. So this two challenge when you develop meta-heuristic algorithms. So we need robust algorithms that can simulate exploration and exploitation. Exploration means we need to explore all the search area, and exploitation we need to mere robust local search or neighborhood points because neighborhood points can improve the performance and develop accurate solution. So if the algorithm is weak algorithm or some pure algorithm can suffer from premature convergence and slow convergence. This premature convergence, the algorithm can go quickly for any solution and without any improvement. Or slow convergence, the algorithm will be stagnate or flat algorithm or flat curve. So we need to make trade-off between convergence and accuracy. Between convergence and accuracy. So there is two challenge: exploration and exploitation, and they conflict to each other. So we need to make balance between exploration and exploitation because there is like trade-off point, and we need to go to this trade-off point. So next slide. Hybridization. So hybrid, we need to or more algorithms that can work together and to produce more robust algorithms. So we need to combine the advantages of some algorithms together. So in this combination, we can go to very accurate solution or improve the performance of algorithm when faces like high dimension problem, multi optimal problem, or any challenge problems. Next slide. So motivation for hybridization. So we need to make some robust algorithms. Robust algorithms. This is the main motivation. So there is some unified purpose and multi-purpose. Unified purpose, we need to make some or sub algorithms to solve the same problem directly. But multi-purpose, we need to make multi improvement inside the algorithm. Next slide. So for this step, we need to make two types of algorithm, like sequential or multi-stage algorithm. As algorithm can work like stage one, this algorithm can work, and the stage two, this algorithm can work, and the algorithm can work in stages, in multi-stages, stage one, stage two, stage three, and so on. or sequential algorithm. The algorithm can work sequentially. So algorithm can feed the other algorithm. For the second one, sequentially, algorithm one can develop or can feed the another algorithm and so on, like circle. So the third class or third type is parallel algorithm or parallel structure. We can two algorithms work in parallel and that follow, and we can pick up the best performance from these two algorithms which work in parallel. Next slide. Is this like the structure of genetic algorithms? This two algorithms and two algorithms from genetic, and they work in parallel, and they in the last stage we can got the uh, best performance from those two parallel algorithms. Next slide. So this advantage and the challenge of hybrid algorithm. So the first disadvantage is the naming. So some researcher can write big name for this hybrid algorithm, and this makes some confusion, like HBSOBFCG. This not mere confusion name. So it may be interesting to compare the name of hybrid algorithm, collaborative, commutative, and so on. So if you need to make some integrative algorithm, sequential algorithm, and hybrid algorithm, we have to put the name directory. So the another challenge is the complexity of algorithm because the hybridization make more complex algorithm, and this can make offer take more time and take more computational. So the last one is the computational speed. So this can weak the speed of the algorithm. So we need hybridization, but we need to avoid some challenge. We avoid naming task or complexity or speed, and we need more fast algorithm with more robust performance. Next slide, please. So recommendation for future. Simple algorithms are preferred than more complex algorithms. So short name is more preferred. So we need to classify algorithm directly. This algorithm like collaborative or integrative or hybrid, because some researcher can make like hybrid algorithm and there is both name integrative algorithm. So we need to make the exact name, like if this is cooperative or this integrative or this like hybrid algorithm. So there is references, and thank you for your attention. And please, the next file is contact for me, like ResearchGate account or Google Scholar account in the next slide.
Any question from audience, please? Robi?
Professor Rizk, there is a question from the audience.
Yeah.
Yes, he is asking now.
Hello.
Hello?
Hello, sir. Are you audible?
Yeah. Yeah, I heard you. Yeah.
Sir, I have one question that how the disadvantage of hybrid app means hybrid algorithm can help
Please, can you repeat again, please?
Sir, you told that there are some disadvantages of hybrid algorithms.
Yeah.
So my question is how the disadvantages of hybrid algorithms can help if there is a
Hybrid algorithms. Yeah, hybrid algorithm can improve the accuracy and they can improve the can work nicely with a high dimensional problem or multi-optimal problem because in hybridization we take the advantages of these algorithms and combine this advantage together. But take care when you develop hybrid algorithm, you have to go to the point how to hybrids, how to make the name of hybrid algorithm. But as I took in the start of the slides, I took this hybridization is good for multi-dimensional problem or high dimensional problem or multi-optimal problem. But this disadvantage can occur because this hybridization, if you don't make some compromise this advantage together, we have a very complex algorithm and the computational speed algorithm. So you have to decide how to combine this advantage together in fast way.
okay, sir. Thank you, sir.
Thank you, sir.
Thank you. Thank you,
Sir,
sir.
one more question, sir. Hello?
Yeah. Hello.
Sir, what is the easiest way to measure the complexity of a complex algorithm?
What is that? Sorry?
What is the easiest way to measure the complexity of a complex algorithm, sir? You mentioned in your slide that, about the complex algorithm.
Complexity, like complexity of this, if you make more evaluation inside the coding, if you have code and you have more powerful function in evaluation, this can make more complex algorithm. Yeah, the complexity sometimes depends on the time and the storage of the machine or storage or the coding. If you have more storage, this can this make some complexity. If you like it's like time, it's like storage of the computational. Yeah.
Thank you, sir. Sir, before present your next slides, can you please on your video?
Next
Hello?
slide. What?
Can you turn on your camera? We want
Please
to
turn on
see
your
you once.
Yeah, sir. Please turn on your camera, sir, once. Link আবার গন্ডগোল হয়ে যাবে কোন না Hello, sir. Can you hear us, sir?
Are we audible, sir?
Sir, yeah.
Yes, sir. Sir, can you open your cam so that we could snap a picture with you?
I think it's open now. I don't know.
Sir, you are not visible,
You
sir.
are not visible to us, sir. Could you
Okay, I will try.
turn on your camera once?
It's also.
Yeah, I will try. Yeah, give me a second. Hello, Professor.
Sir, sir,
I will try. Yeah. Is it visible now or not?
No,
no, sir,
not yet, sir.
Not yet, sir.
Not yet. I will try. Yeah, give me a second, please. I will try. I will try. Give me a second, please.
Yeah, it's visible now, sir.
Visible now or not?
Yes, sir. Now it is visible.
Okay, thank you.
Sir, hello.
Yeah.
Sir,
Hello.
on behalf of our institution, our honorable principal, sir, want to welcome you, sir.
Thank you so much. Yeah.
Most welcome, sir. I myself,
Thank you so much.
Dr. Dinesh Das, principal of this institution, would like to invite you in our conference. We are very much proud and we're very much glad to have you in this for your contribution in this international conference. Since you are in the long distance in Egypt, still you are with us. That's why you are very much happy and proud.
Thank you so much. Thank you. Thank you for nice words and kind words. Thank you so much. Thank you, sir.
Okay, I was not here, but when the coordinator asked me that you are presenting, for a while I came to meet you just through online, and it is a great contribution. Your contribution in this conference will be ever remembered by our institution. Thank you, sir.
Thank you. Thank you. And also, I send my research gate and Google Scholar to Professor Siddhartha, and he can share now. And I am happy to cooperate with you and giving some common research. Yeah.
Okay, sir. Give
Because
us
my research focus on energy system, decision making system, and optimization algorithms. And I have recently now published one paper in green hydrogen for like if you need to refueling station using green hydrogen. So this is my recent paper in this area. So I am happy to cooperate with your researcher and your institution and so on.
Okay, thank you, sir.
Sir, give us
Thank
2
you so
minutes.
much.
Give us 2 minutes. We will just open your second slide.
Thank you.
Just give us 2 minutes, sir.
Yeah, no problem.
Yes, sir. Please continue, sir.
Is it visible to you, sir?
Thank you so much. Yeah.
Sir, please continue, sir.
I suppose that Risk has already completed his talk and it was a nice presentation. Although he has been notified only a day before yesterday. It is so kind of him that he has accepted my invitation to come down and present his presentation. Anyway, we'll be getting in touch with you, Riz, for further collaboration. And I would like to request the organizers to share the vote of thanks to Professor Riz.
Thank you, Professor. Thank you, Professor.
Mic লাগবে না, স্যার।
দরকার ছিল না, স্যার। Okay, thank you very much, sir.
Thank you so much. Thank you, Professor. Thank you.
We have you, and there are so many undergraduate students and PG scholars, and I hope they will get some inspiration from your talk, and they can start their research work in hybrid algorithms. And if is there any issues or any queries, I think they will mail you for their guidance, and as they are very new for their research work. And I hope you know that this is a general degree college, and there is a computer science department. There are so many undergraduate students. They are very much energetic, and they would like to continue or initiate their research work. And if they need any kind of help, we are telling our students that they can mail you regarding their queries, regarding their help. That means basically they need some basic materials from which they can start their research work to understand this interesting topic. And again, I would like to thank you very much. I would like to
Thank
thank
you,
from
Professor.
from the organizers, and we hope that we will get you in future for further lecture or speech. Thank you, sir. Thank you very much.
Thank you so much. Thank you. Thank you.
Sir,
I'm happy to hear that, and thank you for organizer and the Professor Sudarsa to give me this opportunity to be with
Please
you.
wait, please wait. Risk, please wait for some
Sir,
time. Please
wait
wait.
for 1 minute.
Yeah, Professor.
We'll share your appreciation certificate, sir. Give us 2 minutes, sir.
Yeah, okay.
Sir, this is your appreciation certificate, sir, on behalf of our conference.
Thank you so much. And if you send it to Professor Sudarsa to send me in WhatsApp or email, or yeah.
Thank you. Thank you.
This I will be sending you right away. You will be just getting your certificate on your WhatsApp immediately. Okay.
Okay. Thank you, Professor. Thank you so much.
Thank you very much. Bye. Bye.
Bye bye. Bye. Yeah. Have a nice day. Bye bye. Yeah.
Thank you. Thank
Bye.
you. Thanks a lot.
Thank you so much. Thank you. Bye bye.
Thank you very much.
Very easy. Very easy.
Very easy.
Very easy. Hello.
হ্যালো
হ্যাঁ শোনা যাচ্ছে। দেখছি দাঁড়ান। Hello, sir. Hello, sir. I'm audible.
Yes, you are audible.
Okay, sir. Good evening, sir. My name is Jayanti Dash. I am PhD scholar in IST Shibpur and also assistant professor in IT department at RCC IIT. First of all, I would like to thank my supervisor, Professor Hafizul Rahman sir and Professor Indujit Pan sir for guiding me to best throughout my research. And I would like to express gratitude towards the session chair, organizer and convener of this opportunity to present my research work in the front of you all. So I am presenting my research work. The topic name is droplet routing in digital microfluid biochip using accumulative hierarchical clustering. And the co-authors are Dr. Indujit Pan and Dr. Hafizul Rahman sir. So these are the content to my presentation. Digital microfluid biochip fundamentals, literature survey, motivation, contribution, proposed methodology, result, conclusion, and hello.
Your presentation is not visible.
Not visible.
Yes, your PPT is not visible. Please share your PPT first.
I am sharing. Sir, here. 1 minute, sir. Sir, share it. 1 second, sir.
No. Yes,
1 second, sir.
It is not visible.
Sir, yeah, 1 minute. Sir, is it okay?
Yes. Yes, now it is okay.
Okay, sir. My topic name is droplet routing in digital microfluid biochip using accumulative hierarchical clustering, and my co-authors are Dr. Indujit Pan and Professor Dr. Hafizul Rahman sir. So these are the content: digital microfluid biochip fundamentals, literature survey, motivation, contribution, proposed methodology, result, and conclusion, and last one is a references. So the first slide is a digital microfluid biochip fundamentals. So digital microfluid biochip is a advancement over the continuous fluid flow based biochip. It consists of microarray electrode dedicated to perform tiny droplets manipulated by electrowetting of dielectric method. Okay, so shown in figure 1 and 2, here it is a orientation of two parallel glass plates where the two top glass plates charged with the ground voltage and controlled electrode, remaining the bottom glass plate charged with the control electrode. Okay, and now
So this is the parallelly the unit cell of structure of DMFD figure 2. Next. So now the consider figure 3a. Here the figure show the droplet movement process. In the scenario, this is the sample of workflow layout. Here one net consider over here. So two droplets, one mixing point, and another is a target position is over here. So here we have seen that how to move the droplet from one source to one location to another location. So here if you want to move a droplet from electrode 1 to electrode 7, then the electrode 1 is considered as a current location, and the next and the seventh electrode or seventh location is considered as a next location. Then then current location will be charged the low voltage and control electrode, and high voltage will be charged at electrode 7. Okay, so using the electrowetting dielectric technique, it is easily droplet easily moved from 1 to 7. So we present as some constraint of the droplet movement. We have static and dynamic fluidic constant which need to maintain during this droplet movement. We need to droplet generally moves either horizontally or vertically. No droplets movement in the diagonally direction. So at least one electrode gap surrounding the droplet is to be maintained. Otherwise, during the electrowetting of dielectric mechanism, two droplet will be mixed unwantedly mixed. Okay, so I have shown in figure 4. Here the droplet is reside in the particular position, here the center position, and the orange cells surrounding the orange cells are the critical region where no other droplets will be allowed to enter this critical region, and this critical region is from a static and dynamic constant. So next slide is a literature survey. There are many research articles are available which are dedicated to droplet routing in DMFB or digital microfluid biochip. It is multi-objective optimization problem, but all the work are proposed on the basis of different classical optimization algorithm. What we have seen that the use of machine learning methods is very less use in the particular domain. So recently few works are coming up in the machine learning domain. We have studied some recent promising work which has used to machine learning mechanism in droplet routing field. Some of the prominent works are given here. So first one is a adaptive droplet routing in digital microfluid biochip using the deep reinforcement learning. Here the Lang et al. Developed a policy that dynamically determined droplet path during the real-time observation, and it is also adopt the degradation pattern, and it's only used for the healthy electrode. Next paper is a reinforcement learning based on the droplet routing algorithm for digital microfluid biochip, Colliery et al. They are introduced the Q-learning techniques, and it helps it determine the certain predefined number of optimal path between the source and target, and they are also introduced the stalling and detouring concept using the reinforcement Q-learning policy. Stalling and detouring problem are conflicting remove or decrease the conflicting problem. Okay, so the next paper is a Shaha et al. Paper. The paper name is a deep reinforcement learning approach for optimizing homogeneous droplet routing in DMFB. They are introduce a neural network based technique for homogeneous droplet routing in DMFB, and first of all it identify a set of all possible path using the deep Q learning algorithm, and lastly root compaction is identified, and then select the optimal path from this option. And last one is a deep reinforcement learning approach to droplet routing for anonymous DMFB, Kawakami et al. They are also introduce a deep reinforcement learning based routing algorithm, and it is automatically manage or identify the unknown errors, that is the dynamically or runtime failure of electrode in DMFB. So next one is a motivation. So this is the figure 5, figure 5C. This is the sample workflow layout. Here the two nets are considered, two nets S1 and S2. This is the source droplet. The position is or location is 1. The first net, the position is 1 to move forward to the 27. This is the target position, and the second net, the position source is a 4, and it target position is 20. Okay, so and the yellow cells are denoted the blocked electrode, and this is the blocked this is the information of the net information and the blockage location information. So how to, so next slide is a contribution. So how to move the droplet towards the target. So first of all, using the accumulative hierarchical clustering, first we find the position. First we take the two droplet into the two separate cluster using the concept of accumulative hierarchical clustering. Then that is a first one is a 1, and the second net that is a 4. So first we take a two cluster that is a 1 and 4. Then we find the possible all paths, that is a that is a just adjacent cell, that is a 2. For 1 that is a 2 and 7, and for 4 that is a 3 and 10. Okay, so after finding the all possible path or cells, then we check the blockage cell. So 2 and 7 is not in the not blockage cell, but 3, but net 2, the 3 is in blockage cell. So this part is stop over here. So this is the blockage cell, this part is stop is over here. So the first for first cluster or first source, we find the 7 and 2, and for second we find the 10 cell. So then we append the this cell with the previous cluster and move forward. Then the level 3, we find the two current position, that is a 2 and 7. Then we find the adjacent cell. For 2 it is 3, and 2 it is 8, and for 7 it is 8 and 13, and here 10 it is a 9 and 16. So first we check the blockage cell, and then it check the fluid constant checking. So after checking the blockage cell, path 2 is not considered is over here, because 3 and 8 are is in blockage cell, so only 13 position is available. And for net 4, that is a 9 and 16, that is no problem of blockage cell. Then we check the fluidic constant 13, 9 and 16. If it is not conflict, then move forward. So similar process level 4 is done in over here. And then the level 5, when the current position is 19 and 14 for net 1, and the current position is 22 for net 2. Then the 19 is position 19. For 19 we find the 2 cell. This is the 20 and this is the 25. Okay, and for 14, the next position is 15 and the 20. Same as when we consider the 22, it is a 21, just 21 because this is the bound.
2 minutes. Hello.
Hello.
Madam, please try to conclude within 2 minutes.
Okay, sir. So here the fluidic constant is conflicted, and here the stalling position is process, and over level 16 and 17 are same process, and we get the cluster 1 and cluster 2. Next, this is the proposed methodology algorithm. So first we size the DMFB board, then bounding region is calculated, then the possible all the paths are finding, and then the process are proposed, which are previous slide we say. Next, the resultant results. We have used the Python 3.13 Ubuntu OS version 20, and my benchmark is U at all 2006. My 3 factors is over here: latest arrival time, average arrival time, and total used electrode. So this is the resultant. This is the data set and also resultant. So basically here the test bench are 15 test bench are over here, and total nets are 264, and 264 nets are over here. So basically we compared the Shah et al paper, which is 2023. Then this is the resultant of my 3 main factors: latest arrival time. So this is the my proposed algorithm, and this is the Shah's algorithm. So all the 3 factors are improved